There's a white powder sitting on the laundry aisle of your grocery store right now that dissolves every organic blockage inside any household drain pipe at the molecular level. Not temporarily opens the drain for a week until the clog rebuilds from the inside out. Not manage the symptom just enough to keep you buying another bottle every 3 weeks. Eliminates the cause permanently through a chemical reaction that converts the fat, protein, hair, soap scum, and biofilm lining your pipes into water-soluble compounds that flush away and never come back. Not a $12 bottle of chemical drain gel that warns you not to let it touch your skin. Not a $30 bottle of enzymatic cleaner that needs weekly reapplication. Not a $275 emergency plumber visit for a kitchen sink that a $1 treatment clears in 30 minutes on a Tuesday evening. 1 cup of white crystalline powder from a $3 box in the laundry section. 1 kettle of boiling water. 1 pour. The drain is clear, the pipe walls are clean, and the problem that chemical drain cleaners have been managing for profit is eliminated at the root. The powder is called washing soda, not baking soda, which is sodium bicarbonate and a different compound entirely. Washing soda is sodium carbonate, the alkaline cleaning agent that plumbers and industrial maintenance workers used as their standard drain maintenance compound for a century before synthetic chemical drain cleaners were invented, and the knowledge was quietly moved to the laundry aisle. The drain cleaning services market generates over $50 billion a year in the United States. The chemical drain cleaner retail market adds another $4 billion on top. Every dollar of that combined revenue depends on one foundational principle, that drain maintenance is a recurring problem requiring recurring purchases. A $1 treatment that eliminates the problem permanently destroys that entire business model. They did not suppress this because it failed. They repositioned it as a laundry additive at the precise moment that chemical drain cleaners needed its shelf space. This is the story of washing soda, the drain maintenance compound that every plumber used before synthetic chemicals existed, and the one powder a $50 billion industry prays you never pour down your kitchen sink. If these stories matter to you, the subscribe button and the bell are the best way to make sure this knowledge survives. Now let me take you back to where this all begins. The textile mills of Yorkshire and Lancashire were the industrial heart of the British Empire in the 18th century. They processed enormous quantities of raw wool, cotton, and flax, and the processing required massive quantities of a cleaning agent that could strip natural oils, waxes, and organic residue from raw fiber without damaging it. The compound the textile industry depended on was soda ash, sodium carbonate, produced initially from burned seaweed and later manufactured chemically from salt and limestone after the LeBlanc process was industrialized in the 1780s. Sodium carbonate was not simply a textile compound. It was the universal cleaning agent of the industrial era. Laundries used it to break down fats and proteins in soiled linen. Breweries used it to clean fermentation vessels. Hospitals used it to sterilize surgical equipment before germ theory had been articulated, and plumbers and maintenance workers in the mills, factories, and municipal systems of the 19th century used it as the primary compound for maintaining the cast iron drain systems that carried wastewater away from industrial operations. But the use of alkaline minerals for drain and waterway cleaning goes back much further than the Industrial Revolution. Ancient Roman engineers used alkaline mineral solutions to clean and maintain the interior surfaces of their aqueduct and drainage systems. Roman texts from the 1st century LAD document maintenance crews flushing the Cloaca Maxima, the great sewer of Rome, with heated alkaline solutions, derived from mineral deposits in wood ash lye, to prevent the fat and organic buildup that restricted water flow. The practice of periodic alkaline flushing of drain infrastructure was standard Roman engineering protocol. In medieval Europe, households across France, Germany, and the British Isles maintained kitchen drainage channels by pouring heated wood ash lye, a naturally alkaline solution of sodium and potassium carbonates, down the drains monthly as standard housekeeping. Japanese households during the Edo period used heated alkaline rice ash water to clear grease and food residue from kitchen drains in urban Kyoto and Osaka. Traditional Chinese households used similar wood ash solutions for drain maintenance, documented in domestic management texts from the Ming Dynasty. Every civilization that cooked with fat drained water through channels, and observed that those channels clogged over time arrived at the same alkaline cleaning solution independently across 4 continents in 20 centuries. Now here's what happens at the molecular level when washing soda contacts the organic buildup inside your drain pipes. And this is the part the chemical drain cleaner industry does not want explained in plain language. Sodium carbonate dissolved in hot water produces a strongly alkaline solution, at pH 12 to 13. At that alkalinity, two chemical processes occur simultaneously. First, saponification. The alkaline solution reacts with the accumulated fats and cooking oils coating the pipe walls and converts them into water-soluble soap compounds that wash away with the drainage flow. The grease does not get pushed downstream. It gets chemically converted into a compound that water can carry. Second, alkaline hydrolysis. Proteins, hair, food residues, and the dark biological slime-coating old drain pipes break down under alkaline conditions into smaller water-soluble molecules that flush through the system. The organic accumulation that causes slow drains is not mechanically scraped away or dissolved by harsh oxidizing chemistry. It is chemically converted into compounds that water carries through the pipe. Here's the critical distinction that the chemical drain cleaner industry has spent decades obscuring. Sodium carbonate does not harm your pipes. The alkaline hydrolysis it produces acts selectively on organic material and does not react aggressively with any material pipes are made of. Cast iron, PVC, copper, ABS plastic, galvanized steel, sodium carbonate solution is chemically inert toward all of them at drain maintenance concentrations. The pipe is unaffected while the blockage is eliminated. Chemical drain cleaners work differently and destructively. The sodium hydroxide in branded drain gels reacts with organic material faster, but also reacts measurably with metal pipe surfaces, particularly older cast iron and galvanized steel. Every application removes a thin layer of metal from the pipe surface along with the organic blockage it treats. Over years of use, this cumulative corrosion contributes to the pinhole leaks and joint failures that cost homeowners thousands in emergency repair. The chemical drain cleaner that clears your drain today is advancing the timeline of the plumbing failure you will pay to repair in 5 years. A materials science study from Cornell University tested the corrosive effect of sodium hydroxide drain cleaner solutions on both cast iron and PVC plumbing materials over 12 months of simulated weekly use. The sodium hydroxide solutions caused measurable pipe wall thinning in the cast iron samples. Sodium carbonate solutions tested in the same protocol showed zero measurable degradation on any pipe material. If you have made it this far, you already understand more about drain chemistry than 99% of homeowners and most retail staff selling chemical drain cleaners. Subscribe and share this with someone still paying $12 for a gel that corrodes their pipes while temporarily managing a clog. Now stay with me, because what comes next is the part they really do not want you to hear. The American drain maintenance market hit $50 billion in 2024 when you combine service calls, chemical products, and emergency plumbing repairs, downstream of pipe degradation. Brands like Drano, Liquid Plumber, and Green Gobbler control over 60% of the chemical drain cleaner shelf space. The active ingredient in most of those products is sodium hydroxide at 5 to 15% concentration in a carrier gel. That sodium hydroxide costs pennies per pound to produce at industrial scale. The markup on a $12 bottle of branded drain cleaner exceeds 800%. The speed of sodium hydroxide reaction is both the selling point and the fundamental limitation. The aggressive reaction dissolves the accessible outer layer of the blockage rapidly, and the drain opens. But the reaction is diluted and neutralized before it penetrates deep into the dense accumulation of fat, hair, and biofilm coating the pipe walls. Within days to weeks, the dissolved outer layer is replaced by new organic material deposited by normal drain use. The blockage rebuilds from the inside out, the drain slows again, and the customer buys another bottle. The cycle continues. The plumbing trade understood this cycle long before the first bottle of chemical drain cleaner was sold. Commercial kitchen maintenance crews, who manage the highest demand drain environments in any building, do not use chemical drain cleaners. They use alkaline and enzymatic treatments applied on scheduled maintenance cycles that break down organic accumulation continuously rather than reactively. The same principle that sodium carbonate applies, scale to commercial volumes. You cannot patent sodium carbonate. It has been commercially produced since the 1780s, and the chemistry of alkaline saponification cannot be owned. You cannot create a subscription service around a $3 box of washing soda from the laundry aisle. You cannot generate recurring retail revenue from a product that the customer buys once per quarter and that eliminates the problem rather than managing it. And you cannot justify a $12 bottle of pipe-corroding sodium hydroxide gel when a $1 cup of sodium carbonate achieves a deeper, safer, and more permanent result. So the industry did exactly what it always does when a cheap, unpatentable solution threatens a high-margin product line. They repositioned it. They moved washing soda to the laundry section and filled the drain cleaner shelf with branded sodium hydroxide products at 800% markup. They trained retail placement to ensure that no consumer standing in the drain cleaner aisle would ever see the product 3 rows over that outperforms everything on the shelf at 1/10 the cost. The knowledge was not banned. It was simply retail engineered into invisibility. I need to be honest about the limitations, because credibility matters. Washing soda works brilliantly on organic drain buildup, including grease, fat, protein, soap scum, hair matrices, and biofilm. It will not dissolve mineral scale, tree roots that have invaded sewer lines, or structural pipe damage, for complete pipe obstructions caused by non-organic material, or for root intrusion in underground connections. You genuinely need a mechanical snake, or professional hydrojet. But the overwhelming majority of residential slow drains, roughly 90%, are soft organic buildup in kitchen sinks, bathroom sinks, showers, and bathtubs, and for that 90%, washing soda eliminates the cause rather than managing the symptom. Now here's exactly how to do it. Step 1. Go to the laundry aisle of any grocery store and purchase a box of washing soda. The label will say sodium carbonate or washing soda. Do not buy baking soda, which is sodium bicarbonate and operates on a different, less effective chemistry for drain maintenance. A standard box costs between $2 and $4 and contains enough material for dozens of drain treatments. Step 2. For monthly preventive maintenance that stops slow drains from ever developing, bring 4 cups of water to a boil. While the water heats, pour 1 cup of washing soda directly into the drain. Follow immediately with the boiling water poured slowly and steadily over 2 to 3 minutes. The hot alkaline solution penetrates the pipe walls and dissolves fat and protein accumulation before it builds to a level that affects drainage. 1 treatment per month per drain. Total cost, approximately 15 cents. Step 3. For an existing slow drain that already has organic buildup, use the combined treatment. Pour 1 cup of washing soda down the drain. Follow immediately with 1 cup of white distilled vinegar. The reaction produces vigorous bubbling that physically disrupts the structure of the blockage, while the alkaline solution attacks the organic material chemically. Let the reaction work for 30 minutes without running water. After 30 minutes, flush with 4 cups of boiling water poured slowly. Repeat on 3 consecutive days for severe accumulations. Step 4. For kitchen drains where cooking grease is the primary issue, increase the washing soda to 2 full cups per treatment and follow with the boiling water flush. Fat saponification requires higher alkalinity than protein hydrolysis, and kitchen drain accumulations are primarily fat-based rather than the hair and biofilm typical of bathroom drains. Step 5. For shower drains where hair is the primary blockage, remove the visible hair mass manually with a drain snake or a simple hair catching tool first. The washing soda dissolves the biological matrix that binds the hair to the pipe wall, but dense hair tangles respond faster when physically removed before the chemical treatment cleans the pipe walls underneath. Compare the cost. A monthly washing soda maintenance schedule across 4 household drains costs under $1 per month, approximately $12 per year for complete drain system maintenance. A single bottle of branded chemical drain cleaner costs $8 to $15 and treats 1 to 2 drain events before the clog returns. The average American household spends between $60 and $180 per year on chemical drain products that manage symptoms without eliminating causes. Over 10 years, that adds up to $600 to $1,800 in retail drain products alone before the emergency plumbing repairs that chemical pipe corrosion helps accelerate. A retired plumber in suburban Chicago documented his recommendation of washing soda to residential clients in an online trade forum in 2022. He had spent 30 years in the trade and estimated that 70% of his residential service calls for slow kitchen and bathroom drains could have been prevented entirely if the homeowner had poured 1 cup of washing soda down the drain once a month. His total recommended cost per household per year was under $12. His average service call invoice for the same problem was $245. The chemistry inside that $12 bottle of branded drain gel is concentrated sodium hydroxide that clears the outer layer of your blockage rapidly while corroding your pipe walls measurably and with every use. The chemistry inside a $3 box of washing soda has been maintaining drain infrastructure since Roman maintenance crews flushed the Cloaca Maxima with alkaline mineral solutions 2,000 years ago. One requires a warning label, a marketing budget, and a retail price that sustains a $4 billion product category. The other requires a kettle, a measuring cup, and 15 cents of your Monday evening. Every civilization that piped water and cooked with fat understood this chemistry. Roman drain crews knew it, flushing the cloaca maxima. Medieval European housewives knew it, pouring ash lye down kitchen channels. Japanese households knew it using rice ash solutions in Edo period Kyoto. British textile mills knew it, maintaining cast iron drainage through the Industrial Revolution. LeBlanc industrialized the compound in the 1780s. Every plumbing apprentice before 1925 learned it as standard practice, and the grocery store 3 miles from your house sells it in the laundry aisle for less than the cost of a cup of coffee. $50 billion in annual drain maintenance revenue depends on you never walking 3 aisles past the drain cleaner section. $12 bottles of sodium hydroxide gel depend on you believing that clearing a drain requires a pipe-corroding chemical with a skull on the warning label. And $245 plumber visits that depend on you never pouring 1 cup of washing soda and 1 kettle of boiling water down your kitchen sink once a month. This knowledge did not disappear because it stopped working. It disappeared from the consumer awareness because it worked too well and cost too little for anyone to build a recurring revenue product around it. Alkaline saponification does not care about shelf placement strategies. Sodium carbonate does not negotiate with marketing budgets, and a compound industrialized in the 1780s has never charged a licensing fee. If this video changed how you think about the bottle of drain cleaner under your sink, the slow drain in your shower, or the $3 box of washing soda sitting in the laundry aisle right now, then subscribe and share it now. Every single share puts this knowledge in front of someone the plumbing products industry assumed would never walk 3 aisles past the drain cleaner section. And every subscription keeps this channel digging deeper into the secrets they thought were sealed forever.